well, so I'm before I get to pre-calc FRQ4 from this year's test, I just want to know anyone out there know a tool that I can use to take my TikToks and automatically post them to YouTube? Because I have like the ones that I've been posting, and I can take the newer ones and just post them on both. But I want to know what I can do to automate posting all the ones from before. So if you know that, let me know. If not, let's just go. Yeah. Just gonna start. So I know that if I want to turn this exponent into a fraction that looks like this, then my exponent has to be negative. If I have e to the negative 1, then that's the same as saying 1 over e. Right. So if I want to have 1 over e to the 6, then I need to have e to the negative 6, which again would equal this thing, because e to the negative 6 is just 1 over e to the 6. So this has to equal e to the 2x, meaning that these bases can like cancel. So we have negative 6 equals 2x, meaning that x equals, sorry, they wouldn't be equal, but x equals negative 3. So that's this answer. X is negative 3. Solve this one. Well, let's just say that this equals 3 because that's what we're going for. Um, just remembering how logarithms work, we're saying that this number to the power of this number should equal the inside part. So 2 to the power of 3 equals 5x. So 2 to the power of 3, that does not look like a 3. 2 to the power of 3 equals 5x. 2 to the power of 3 is 8. So we can say 8 equals 5x. And now we want to divide this by 5. We want to divide both sides by 5. These cancel, so I just get that x is 8/5. What next? Yo, it's not letting me scroll over. Ugh. Okay, fine. We'll zoom out and then zoom back in. Rewrite this as a form with 7 to the power of something. Multiplying means you can just add. So 3x plus 1 plus x. You're just adding. So 3x plus 1 plus x. We combine like terms. 3x plus 1x, which is what this is. There's the invisible 1 there. Is just 4x. So this instead of 3, this is just 4x plus 1. And now again, we can't forget the base. So it's just 7 to the power of all this. Rewrite k where sign appears once. This one's pretty weird, to be honest, but you're combining two different identities here. Well, one identity and like one kind of thing that you should just know. I guess both identities, but either way. Sine of 2x. Let me go color code here. This can be rewritten as 2 sine x times cosine x. Right, and now my red bit, secant, is the same as, so times 1 over cosine. Secant is 1 over cosine x. Right, so now let's just look here. The cosine here cancels with this cosine here. So all I'm left with is 2 sine x, which would mean that this is my answer. So 2 sine x. Last question. The function m is given by that thing, where between 0 and 2 pi is there an output value of 1. So tan has an output value of 1 because tan is just sine over cosine. So whenever sine and cosine are the same, that's when tan has an output value of 1. On our unit circle, our x value and our y value, this is our interval, by the way, our x value and our y value are going to be the same, like right here in the middle at this 45-degree angle. So what is the measure of that angle? That angle is going to be, what? This is 2 pi, or pi over 2, so in between is pi over 4, right? So I know that tan squared of pi over 4 would equal 1. But notice that in place of 3x, I have pi over 4. So I should say that pi over 4 equals, so hard to write, 3x. And now if I want to like solve it fully, I need to divide both sides by 3. So these 3's cancel, and then I would divide this by 3, which is the same as multiplying by 1/3. So I get that 1 times pi is just pi. And then, this is divided by, and then 3 times 4 is 12. Pi over 12 equals x. That's it. That's all of FRQ4. Bye-bye.